Today we are going to start with the second term portions. In that, the lesson is atomic structure. In atomic structure, we are going to learn that you know already that in the atomic structure there are 92 elements occur in the nature, and the remaining elements it is made in the laboratories. So out of the 118 elements worldwide, 118 elements are there. In that, 92 elements occur in the nature, and the remaining elements are synthesized in the laboratories. So how these all elements are made and what is the atomic structure of these all elements will be coming across in this lesson. So some of the elements or some of the metals you come across as copper, iron, gold and silver, some of the elements found in the nature. So these all elements are found in the nature, and some like nectinium, promethium, neptunium and plutonium are synthesized in the laboratories. So each element has its own atomic structure, okay, and this atomic structure, the word atom, each and every element is made up of atoms. That also you have studied in your middle school, that means in the 7th standard, the atomic structure. In that, the word atom is derived from the Greek word atomos. The tomos means smallest divisible particle and atoms means smallest divisible pattern. All the elements are made up of a simplest unit called the atoms. Okay. So in this lesson we are going to learn about how each scientist or each scientific theory about the how they found out how the atoms are organized or how the atoms are arranged inside the each element. So here the first scientific theory about an animal was given by John Dalton, then he was followed by George Thomson, then Rutherford. So these all scientists have learned about the how these elements or how what is the atomic structure of each element. So the first we will study about the Dalton's atomic theory. According to him, the main things what he told in the Dalton's theory for the atomic structure was all the matters are made up of extremely small particles called as atoms. So all the elements, whether it is artificial or whether it is naturally, all it is made up of atoms. Okay. The second point he told us, atoms are the same element, identical in all aspects. So atoms of the same element, that means same element will be having the atoms of the same size, shape, mass and properties, everything will, if two atoms of hydrogen or two atoms of oxygen is given, each what is the atomic structure will be the same in the shape, size, mass, everything will be the same for both the oxygen elements. And next he told atoms of different elements have different sizes and masses and possess different properties. So different atoms of different elements will be having different sizes and masses and possess different properties. Next point he told us atoms can neither be created nor be destroyed. It can be neither created also and neither it can be destroyed. Atoms of different elements may combine with each other in a fixed simple ratio to form molecules. So these all atoms will join together to in a ratio to form different fixed simple ratio to form different molecules. So these are the postulates. So these are the what the Dalton found out about each atom. And the last point he told us an atom is the smallest particle of matter that takes part in the chemical reaction. So these are all the postulates what the Dalton has told about the atoms. So what all he has told, let us recapitulate. All the matters are made up of extremely small particles called as atoms. Atoms of the same elements are identical in the shape, size, mass, everything will be of the same element will be identical. Then he told that atoms of different elements have a different size, shape and masses. Then atoms can either be created nor destroyed. Then he told that atoms of the same element by combine in a fixed ratio to form the molecules. Then an atom is the smallest particle of matter that takes part in the chemical reaction. So these are the 5 postulates or the 6 postulates told by the Dalton or John Dalton. So do you know John Dalton, son of a poor weaver, began his career as a village school teacher at the age of 12. He became the principal of the school 7 years later. In 1793, he moved to Manchester to teach physics, chemistry, and mathematics in a college. He proposed his atomic theory in 1803. So, atomic theory by Dalton was proposed in 1803. He carefully recorded each day the temperature, pressure, and amount of rainfall from his youth till the end. He was a meticulous meteorologist. Meteorologist means who studies about the climatic change. Okay. So, from his younger age itself, he started to calculate how many centimeters the rain was there, what are the climatic changes taking place, everything he used to observe and record it and keep. Now, what are the advantages of the Dalton's atomic theory? Dalton's theory explained most of the properties of the liquids and gases. So, most of the properties of the liquids and gases was properties were mentioned by the. This explains the law of chemical combination and the law of conservation of mass. In this, he explains the law of in his advantages of atomic theory. He explains the law of what all chemical combination and the law of conservation of mass. This theory helps to recognize the molecular differences of elements and the compounds. It also helped to recognize what are the molecular differences between the elements and the compounds. So, in his Dalton's theory, two things he was able to say the properties of liquids and gases, then the laws of chemical combination and the laws of conservation of mass. Then it also helps him to find out the molecular differences of elements and compounds. Now, what are the limitations? What all the limitations he had in the Dalton's theory? Atom is no longer considered as the smallest indivisible particle. He told that in his theory, he told that atom cannot be considered as the smallest indivisible particle. Atoms of the same element are different, have different masses. So, atoms of the same element itself of the atoms of the same element will be having different masses, different weight. Atoms of the different elements may have same masses also, isobars. Sometimes made up of same kind of atoms may have different properties. Same kind of atoms will be having different properties also. Coal, graphite and diamond are made up of carbon atoms, but they differ in their properties. So, coal, graphite and diamond, everything is having carbon content, but it will be having the different properties. Now, the fundamental particles. What are the fundamental particles? So, in 1878, Sir William Crookes, while conducting an experiment using a discharge tube, found certain visible rays traveling between two metals. So, this is a discharge tube. See, this what you are seeing in this one is the discharge tube. He saw that there is a visible rays traveling from the two metal electrodes. These rays are known as the Crookes rays or the cathode rays. So, he named it as the Crookes rays or the cathode rays. He saw that between two metal electrodes, a certain visible rays is traveling from one end to the other, and he named as the cathode rays or the Crookes rays. The discharge tube used in the experiment is now referred to as Crookes tube, or more properly known as cathode ray tube. It is also now it is named as CRT, cathode ray or the Crookes tube. Cathode ray tube is a long tube filled with a gas and sealed at both the ends. It is a long tube which I have shown in the picture. It is a long tube. It is both sealed on both the sides. Sealed means closed. Okay. It consists of two metal plates which act as electrodes. So, these two metal plates. See, this one line is shown in bluish color, both the ends. That is called as the electrode plates. So, it consists of two metal plates which act as electrodes connected with a high voltage. So, in between that there is a high voltage passing through it. The electrode which is connected to the negative terminal of the battery, if it is connected to the negative terminal of the battery, it is called the cathode. The electrode connected to the positive terminal is called as the anode. So, when the electrode which is connected to the negative terminal of the battery is called as cathode, and the electrode which is connected to the positive terminal is called as the anode. There is a side tube which is connected to a pump. There is a side tube also which is connected to the pump. The pump is used to lower the pressure inside the discharge tube. So, why it is connected to the pump? so that the pressure inside it will be low pressure will be maintained inside that discharge tube. For that purpose it is connected to a pump. Now, do you know electricity when passes through air removes the electrons from the gaseous atoms and produces cations. This is called as electrical discharge. They mentioned what is electrical discharge. So, what is electrical discharge? When electricity is passed through the air, it removes the electrons from the gaseous atoms to produce cations. This is called as electrical discharge. Now, discovery of electrons. When a high electric voltage of 10,000 volts or more is applied to the electrode of a discharge tube containing air or any gas at atmospheric pressure, no electricity flows through the air. So, when a high voltage, that means 10,000 volts of electricity is passed through a discharge tube containing air or any type of gas, the electricity will not pass. However, when the high voltage 10,000 volts is applied to the electrodes of a discharge tube, two electrodes I showed, no, one which is connected to the negative of the battery is called as cathode and one to the positive is called as the anode. So, that discharge tube containing air or any gas at a lower pressure of about 0.001 mm of mercury, a greenish glow is observed in the walls of the discharge tube. When the electricity is passed, a greenish color glow or a light, small light is visible inside that discharge tube. This observation clearly shows some invisible ray coming from the cathode. So, this shows that some invisible rays is coming from the cathode. Hence, these rays are called as the cathode rays. Later, they were named as the electrons. So, these rays are called as the cathode rays and invisible rays are called as cathode rays, and later on it was named as electrons. Now, properties of cathode rays. Cathode rays travel in straight line from cathode towards the anode. Always the cathode rays will travel in a straight line from cathode to anode. Cathode is the negative and anode is the positive. Cathode rays are made up of material particles which have mass and kinetic energy. Cathode rays are deflected of both the electric and magnetic field. Deflected means it will show the deflection in the needle. If a needle is kept, it will show the deflection. That is called as, in the electric field also, in the magnetic field also, it will show the deflection. They are negatively charged particles. Always the cathode rays are negatively charged particles. The nature of the cathode ray does not depend on the nature of the gas inside the tube. So, whatever it may be the gas, always the cathode rays will not show any change in that. Always it will be in the, I will be having the negative charge. Tube or the cathode used. In the above, do you know? The fact that air is a poor conductor of electricity is a blessing in disguise for us. Imagine what would happen if air had been a good conductor of electricity. So, wherever we attempt electricity is passed, we will get the shock. All of us would have got electrocuted when a minor spark was produced by accident. So, whenever we are going here and there, when the electricity is passed by mistake, what will happen? We will get the shock if air was a good conductor. Now, in television tube, cathode rays are deflected by magnetic fields. A beam of cathode rays directed towards the coated screen on the front of the tube, whereby varying the magnetic field generated by electromagnetic coils, the beam traces the luminescent image. So, in the back of the old TVs, you can see like this, the projection will be seen where these cathode rays are there, and from there only the images are transferred and come into the front screen. So, this is the properties of cathode rays, how the electrons was discovered, and what are the properties of the cathode rays that we studied in this class. Next class we will go for the discovery of protons, then the discovery of the neutrons. Thank you, students.